Welcome to the 2022 Concord IA seminar. Quick introduction, my name is Dennis Coulbourn. I am the Eastern Regional Sales Manager for Lycoming Engines. A little about me, I've been with Lycoming approximately 17 years. I've held various positions of test cell operator, inspection, assembly. I was a technical rep for 8 years. And the remaining time I've been in this position in sales. So a little bit about Lycoming. Lycoming Engines has been around for about 110 years. We are located in Williamsport, Pennsylvania, which is just right central Pennsylvania. You might have heard of us from the Little League World Series. So Lycoming Engines, our inspiration is to build every engine as though you're going to fly it yourself. You walk through our plant, you will find these banners around. We take that literally, and we have a flight school which uses, or we have a flight club which uses our engines. So we do build every engine because we do fly it ourselves. Our vision is to be the propulsion solution provider recognized and trusted for our products, innovation, services, and customer focus. So just some old photos from back in the day when Lycoming was we were doing everything in there. You can see the radials, the old building, train tracks running through there. It's kind of hard to see there on the left, but there's a train that runs through there that was for supplies. And today we have cleaned up the area a little bit. It looks a little cleaner. You can see the low center picture in the lower side there. That's the outside of our building now. We've improved it, but it's still the same building from over 100 years ago. So Lycoming today, we have produced over 325,000 engines. 200,000 of those are still active. Our product range is from 5 to 400 horsepower. We have 773 type certificated designs. We hold the number 3 production certificate, which is pretty cool. We've been doing this a long time. We hold a repair station license because we do overhauls. And we also do prop strike inspections, metal contamination inspections, overspeeds, overboosts. So we do hold a repair station for doing those sort of repairs. And we held an AS 9100 Level D Shingo Prize award. You know, we're a manufacturing facility. We take great pride in our manufacturing capabilities. And just a little notes, Lycoming fleets accumulate over 1 million flight hours per month. It's kind of cool when you just how many engines we have out there flying, gathering data for us. It's really a really cool thing. So let's get into the maintenance. That's the reason why we're here. Kind of new-ish for us is the Lycoming electronic ignition system. I'm not going to run through the whole advantages of having this, but kind of wanted some high level, some things that we've seen in the installation of these. It's designed to go to TBO and it does not include any scheduled maintenance, which is nice. So you put it on, you kind of forget about it. It uses the slick style harness, so it's kind of a drop-in. Uses aviation plugs. If you're interested in anything like that, refer to service instruction 1443 for part numbers. And then service instruction 1569 goes through the installation instructions. Some notes that we've kind of just wanted to hit on just to kind of make you aware. The EIS is timed at #1 top dead center as opposed to the magnetos, which are 20, 25 before. It does have a built-in timing verification, so it doesn't require any extra tooling, any extra timing lights to install one of these. And do not perform a high tension lead test with the harness connected. So simply just disconnect the harness if you're doing a high tension lead test. That way you won't fry the board. Cylinder head valve arrangement. So I'll mention things in my presentation with angle valve, parallel valve, and then visually you can kind of see what you have. Parallel valve cylinder head looks like a bowl. It's just like a just a bowl, and that's kind of the parallel valve arrangement. Angle valve, as you can see, it's a little wider, but it's a flat piece of metal, basically, with a flange. And that's the angle valve. It's just, the valves are literally angled in the head, which gives you larger valves, and you'll see these more on higher horsepower engines. We've had different TAPPET configurations, so just be aware of that. So we'll touch on that real quick. It's service instruction 1514 and service letter 220. To determine configuration, basically look at the engine serial number. As you can see there at the 51, that is a narrow deck with flat tappets. We didn't build roller tappet engines in narrow decks. Wide deck is an A. So the 51A tells you that it's a wide deck flat tappet. The 51E is a wide deck with roller tappets. And where this is going to come into place is when you're working on the engine and you're changing some cylinders out, or you're doing some work in that valve train area, there are some different part numbers. So reference service instruction 1514, and then you'll see the difference in part numbers between the flat tappets and the roller tappets. Let's go to cylinder identification. This kind of comes in place when you're replacing cylinders as well, of what type of cylinders you have compared to what rings you're going to need. So service instruction 1181 talks about this. So the color code on the fins between the spark plug and barrel indicates the barrel material configuration. Gray is just plain steel. Blue would be nitrided steel. Orange is chrome plated, and then the green and yellow are oversizes. Cylinders coming out of our factory will give you an all nitrided, so you'll see a blue paint on that fin area. And as far as the spark plugs, that's what the next code is. It's the spark plug to rocker box area. So gray, blue, unpainted, whatever the color of the cylinder is, it's a short reach. Yellow equals long reach. Where this is going to come into play is there are certain engine models where the IO360A series, for example, may have short reach, and they also may have long reach. So if you have a yellow, then you know that you have to have long reach. And that is something that is good to check, because you're gonna make sure that the person prior to you working on that put in the right spark plugs. So that's important to kind of keep an eye on that, so you don't install the wrong plugs. So let's call it the cylinder flange. This will go back to the narrow deck, wide deck. So standard cylinder flange, also known as narrow deck. It's our original cylinder flange thickness used on our engines. It uses internal wrenching nuts as attaching hardware. The higher horsepower engines use a hold down plate. I would say 160 horsepower and up, you'll see that. And it's still used on new production O235s, simply because it's, you know, kind of a lower horsepower engine, and we didn't really need to go with the wide deck in that engine model. So the wide cylinder flange, also known as wide deck, was introduced in the early 1960s. It's a wider flange thickness and larger stud circle. You won't be able to interchange standard cylinder onto a wide deck or vice versa. They simply will not work with the larger stud circle, or smaller, depending on which engine you're working on. It uses external wrenching nuts, except on the 390s and 580s. So there's an exception to every rule, but for the most part, you will see the external wrenching nuts, unless you're working on a 390 or 580. And hold down plates are not used on wide cylinder flanges. So let's talk about oil. I get that question a lot. What should I use? What brand do you guys want us to use? So we'll get right into that. We have a service instruction for oils, and that's service instruction 1014. So I'm referencing that, some high level points in this. We basically go off of mil spec, SAE spec. We don't go by brand name. In fact, we have a service letter saying we won't name it out by brand. But what we require is that it meets those mil specs. Service instruction 1014 lists recommendations for oil weight based on average temperatures, oil used for break-in and operation, and changing oil from mineral to 80 oil after some time in service. We've had some instances where someone has run 200-300 hours on mineral oil, and they just realize that, or something happens. So we have in service instruction 1014, it will talk about that, but basically high level is, once you put the detergent oil in there and start cleaning, it's gonna create some work for the filters and the screens. So you're gonna have to increase your oil change frequencies until everything is all cleaned out. Oil changes, we take oil changes very seriously. We've made it a service bulletin. So reference service bulletin 480. In 25 hours, that's what we want if you have a pressure screen set up. 50 hours if you have a full flow oil filter. And there's an exception to that, and that's if the Mooney TLS Bravo with the TIO 540A F1B in it, that's a 25-hour oil change. If you don't meet those hour requirements, then 4 months. And for dirty and dusty environments, oil change intervals should be reduced accordingly. If you're suffering from some service issues, one thing that comes off the mind when I was a tech rep was this valve sticking on a customer with a lot of sand in the area. And he found a happy medium of 35 hours, and that really kind of cleaned up his issue when it came to valve sticking. Also, every time we recommend you remove the suction screen just to see what's in there, and also, cut the filter open at each time. So here's a 172, and you can see there that's where the oil suction screen is. It's important to change this. This is the kind of the prevent any issue or any damage to your oil pump. So we want that checked every time. And I'll just show you an example of someone that didn't do that. This is a Malibu. This is about several years ago. 800 hours, 900 hours or so. The low oil pressure, high oil temperature. Luckily, everyone made it to the ground safely. But this is kind of what came out of that. Could have been prevented. Could have just avoided a huge bill. Basically, a few dollar gasket and best hour labor. They could have found this and prevented this $65,000 repair. So it's just something to think about. We require it. So I encourage you to check the suction screen each and every time you change the oil. Get a lot of questions about oil analysis. We have service publications on this, 1492 and service letter 171. So when you get a factory engine, or any engine really, or you change a cylinder out, you may see higher values just because the engine is bedding into itself. It's going to create a little more metal until it's broken in. High results do not necessarily mean imminent failure. I have personally never removed an engine out of service because of an oil analysis. I may want to check the filter again, or try to look inside the suction screen where the suction screen is contained to see if there's anything there that the screen missed. But I have not pulled an engine out of service because of this. So you want to do further investigation if you do find some higher values. But the big thing with oil analysis is to do it each and every oil change. I wouldn't do it once every few years just to check the health of your engine. If you're going to commit to it, stay with it each and every oil change. So service instruction 1492 talks about some numbers that you'll see on an oil analysis. So This is our levels of concern, something that you may want to take a deeper dive into the engine. As you can see there, 100, 130 accordingly. And as aluminum goes, it'll be 30 to 40 accordingly. One thing I look at every oil analysis that I've been asked to look at is the silicon. You don't want any more between 8 and 10, and that's for 50 hours. So if you're changing it at 25, then you can cut those numbers in half. Silicon is just some unfiltered air getting into the engine. You want to look for maybe an alternate air door, carb heat not closing all the way, intake tubes leaking, something in that area that's allowing unfiltered air to get into the engine. So we don't have the hard limits, but these are levels of concern through experience of looking at different engines and looking at oil analysis. But refer to those service publications there and they will guide you in if you're going to get into the oil analysis. And if you open up a filter and actually see metal, physical metal, service instruction 1492 will walk you through the particles and recommendations based off of the amount of material, the type of material. It lays it out pretty nicely, kind of gives you some guidance when you're not 100% sure where to take this. And also, if the engine is less than 12 years old, due to our TBO recommendations, a Lycoming Tech Rep can analyze that metal for you, not the oil, but if you sent the metal in to a product support and they can put it in our lab, and a few days later, the lab will come back with it's an AMS XYZ. Typically were used in camshaft, cam crank, whatever the AMS number comes out as. It's a good tool to use. And then near the end of this presentation, there will be contact information for our product support team that can get that submitted for you. And we don't charge for it, by the way, but it does take a couple of days to kind of process it. But it gives you an idea of next steps to kind of help you out. Let's talk about fuel. We have a service publication on that. We have a bulletin that's 398 and a service instruction 1070. Service instruction 1070 identifies fuels approved for our engines. Just so you know that these fuels are approved for the engine, it does not constitute approval for the airframe, specifically when it comes to unleadeds, which we'll touch on here in a second. So in service instruction 1070, you will see table 1, which lists aviation fuel grades, table 2, which is automotive fuel grades, and table 3 is just all their engine models in a chart and what fuels are approved for each of those engines. If you're going to use any sort of automotive fuel, you need to pay particular attention to the requirements and notes pertaining to the fuels. Automotive fuels are, out of the pump is kind of a gamble, unless you don't necessarily know what's in there. So like ethanol, methanol, and alcohol. And until more data is collected, if you're going to use an automotive fuel, use our additive LW16702 to it just adds an extra layer of lubrication that the lead is no longer there. So if you're doing that, we recommend using that additive, which a lot of oils already have that in there. Let's talk about some cylinder head temps and some troubleshooting, getting into some different issues with cylinder heads, temperatures. Lycoming recommends CHTs between 150 and 435 for continuous operation. So when you're in cruise, 435 and under, to 150, which we don't really see 150, but 435 Fahrenheit and under, the cylinders are going to be fine. They are right in the sweet spot. Maximum CHT is 500. On most engines, I believe our 390s are 485. and the owner's manual will have that. So let's talk about if high CHTs are noted. Let's do just some high level troubleshooting, some things that we've found will rectify this issue. Let's do some troubleshooting first. Let's examine spark plugs. Let's look at if it's lean or rich or anything in between. Compare your fuel flows to what's published in the POH and the airframe manual. If you have one nozzle that's a little dirty, you'll see a leaner condition in that particular cylinder. So flow check and clean your fuel nozzles. Ensure that your rigging is correct, that it's going to the full stops. Perform an induction system leak check. We recommend, we don't have a step-by-step, but basically if you use a high volume of air, you'll be able to see if there's any leaks. You can kind of plumb it up through the injector or carb. So like a leaf blower, the blower side of a vacuum cleaner, make sure it's clean. I can tell you a story about that, but you can ask me about it later. Just soapy water and just look at all the induction joints to see if there's any issues. Shop air is typically not enough volume, so I don't recommend using shop air. It just won't give you enough volume, and you need that volume because there's always going to be a valve or two open. So if you have high cylinder head, you want to make sure your mag timing is correct. But a big thing is examine the airframe baffles and seals for cracks, breaks, rips, etc. So here's an ideal setup. You see the cooling air is coming in, it's getting circulated, and it's going over the cylinders, fins to cool the engine, keep the engine cool. So if you have a void anywhere, you'll see the path of least resistance, the air will start escaping around the seal, the baffle, or whatever non-conformance is in there, and it won't be forced over the cylinder fins. And then you'll see some higher temperatures. Here's an example, it's a Navajo. You can see the fingers sticking through there. That's something that you're going to want to fix. And also, even when you're not experiencing high CHTs, if you're in there for an oil change, if something doesn't look right, I would fix it because it's not always going to show high CHTs necessarily, but it will have uneven cooling on the cylinders. We've seen issues with valve burnage, seat burns, things like that, where the CHTs were always within spec, but the cooling air just wasn't even. So when you're in there even for an oil change, something looks bad like this, I recommend fixing it right away. Also, take a look at just the cowling itself. It'll tell you, and you can see this cowling here, there's air escaping by those marks. So look at the baffling, repair it any way it needs to prevent that air from escaping. Oil pressure. Our ops manuals come with all the oil pressure and operating ranges, but on the most part, 55 to 95 for a continuous operation is about the norm. So if low oil pressure is noted, here's a few things that we can troubleshoot to figure out how to get it fixed. Make sure you have the correct level. Make sure you have the right grade and weight for the ambient temperature. Refer back to service instruction 1014 for what we recommend as far as oil grades for a specific temperature. If you're dealing with an O235, there is actually a spacer plate between the accessory housing and the oil filter adapter. If that is not in place, you will bleed off oil. So it's something to look at if you're working on a 235. Verify the relief valve is properly set. So basically adjust that with the wrench or add washers. If you're in there looking at what type of spring or what the ball and seat look like, if there's any abnormality on that seat, take something to it, clean that up. So a minor scratch may seem like not a big deal, but what happens is when that engine, the oil pressure is pumped up and it's pumping up, it's always going to bleed off through that little void on the seat, whether it's a scratch or a nick from some carbon or whatever it may be. So it's always going to hydraulic that ball off of that seat just a little bit. So when the oil is cold and thick, it's not as much as bleeding. But when the engine gets warm and the oil gets thinner, you're going to see a lot more bleed off. So that seat basically really needs to be perfect. If there's any void of any sort of scratch, nick, I recommend dressing that out. And, you know, if you go through those things and you're still below oil pressure, you know, you want to look for your suction screen, you know, go back to my previous slide where that suction screen was never removed. You know, you're not going to get that much oil if your suction screen is clogged. And typically, worst case scenario, the engine just wore out. So you basically examine the engine for internal spill off. So there are tests that our tech reps can recommend to you. Basically, you want to compare the front of the engine to the back of the engine as far as oil pressure goes. And for the most part, any more than 15 PSI drop from the back to the front is cause for concern, and further investigation will be warranted. So as you're working on the engines, we have 3 different types of pressure relief valves. The part numbers there, you can see that. If you have the really short one, it basically looks like an acorn nut, like I have on my motorcycle, but you know, very large. If you have one of those on your engine, it must have a cage type seat in the crankcase. If it does not, that most likely is the problem, and you will need to use one of the long plug or the adjustable one. We make 5 different springs. So if all else fit, you have the appropriate amount of washers. You have it turned in with the adjustment screw, and you just can't get enough oil pressure. Service publication 1776 lists all the spring part numbers and their appropriate strength. And you'll see it listed, and they're color coded, different colors. So if you have a yellow one, you can update to a white one, which is a tighter spring, or if you have too much pressure, you can go backwards with it. 1776, which is available on our website, will show you the different part numbers and their pressures. Oil temp. Our desired oil temperature is 165 to 200. The reason is for 165, you know, on a normally aspirated engine, you're going to be about 50 degrees hotter in the sump. So that takes you above 212. So you're burning out and blowing out contaminants. So that's the reason why the numbers are what they are. So the oil temperature you're seeing is the coolest that engine is doing. So it's basically being read right out of the cooler. Oil temperature max is 245. So if high oil temperatures are noted, we want to go back through and make sure you have the appropriate oil level, the type of oil, the grade and weight. You want to make sure your indication system is calibrated and accurate. If you're seeing really high numbers, you're knocking on 245 or in that area, a good rule of thumb is the oil really starts to thin out above 220. So for every degree above 220, you're going to lose about 3/4 of a pound. So if you're cruising at and it's 245 and your oil pressure hasn't dropped at all, you might have an indication issue, but it's just a rule of thumb, and it's approximates, you know, but you will, above 220 especially, you will start seeing oil pressure drop because the temperature is higher. You want to make sure the oil cooler lines, you want to make sure the lines aren't restricted or blocked in any way. You want to make sure the airflow to and from the cooler is also, being from Pennsylvania, I've worked on some airplanes that sat for quite a while, and there were nests of mice and just random animals in the outlet cooling duct of the oil cooler. So the air can't get out, stagnant air, you're going to have high temperatures. So just something to think about. And also, like the oil pressure seat, the oil bypass valve works in a similar way. So you want to make sure that that is seating perfectly, a 360-degree witness mark right around the face of the vernotherm. Make sure for proper extension, about 180 degrees, it should have grown at least 5 seconds. And check the seat and filter housing for also nicks and damage. You want to make sure that that is perfectly clean. If you see a little mark on a seat, it kind of works the same way. It's going to hydraulic that off just a little bit, and then just get worse as the oil gets hotter. So let's talk about oil consumption. The operator's manual will give you maximum oil consumption. Rule of thumb, you don't have to get your calculator out, but if you're using 1 quart in 1 hour, something needs to be done. And that's pretty excessive too, but something that you want to kind of keep an eye on. You don't want to get down to 1 and 1. One thing I like to just note before getting into some troubleshooting is some engines find their own. If you're getting 10 hours to a quart and your neighbor's getting 5, it may have been just the way the engine was broken in, the way it's being operated. There are a lot of variables. Conditions are many and varied when it comes to oil consumption. One thing I like to note is if you are the one that has 10 and all of a sudden it drops to 5 overnight, you're technically way within the spec, but that's a cause for alarm. It's cause for some further investigation. And here are some things that you can check. If you just recently installed the engine or if it recently changed a couple cylinders out, your new rings may have not seated properly. Cylinder valve may be glazed, which causes oil consumption. Piston rings and or cylinder barrels are excessively worn. Valve guides are worn. And piston rings may be broken, specifically the oil control ring, which typically happens more, I've seen in my past, on turbocharged engines, just the higher temperatures, and they get the oil control ring will get some coking and get stiff and could possibly break. And this is rare, but it's something that you always want to make sure when all else fails is oil is being siphoned from the engine while in flight. There are some certain airframe manufacturers that recommend a certain location for their breather exit. So it's something to look at if you've run through a lot of these troubleshooting steps and still have high oil consumption. Let's talk about the wobble check, exhaust valve check, service bulletin 388. Basically what this does is it gives you the condition of your exhaust valve and guides. For helicopters, we recommend 300 hours. In fact, Robinson recommends the first 100 hours and then 300 additional. All other engines are 400 hours or earlier if you suspect of sticking. Service instruction 1485 does change that 400 hours to 1,000 or midlife. So basically, you have a high chrome valve guide that goes from 400 to 1,000, and we've been building those with our cylinders with high chrome valve guides for 30 years. There's a service instruction 49. We'll give you the date, but it's been a long time we've been using the high chrome valve guides. So the allowable wobble is parallel valve is 15 to 30, and the angle valve is 15 to 35. So clearance issues, what we find is loose. If it's loose, it's over 30 or 35. It is caused by excessive wear and requires replacement of valve and guide. Or if you have a shop that can change guides out to have all the right tooling, then changing the guide is appropriate, and that will fix it. If it's tight, it's caused by debris and carbon buildup in the valve guide. It will require valve cleaning, and we have a publication on how to do that, and that is Service Instruction 1425. And as always, just to avoid it, we have a service publication, Service Letter 197, that talks about the basically the maintenance of the aircraft on how the engine is being operated. It's a good read if you have struggled with any sort of valve sticking. So how do you know you have it? The old morning sickness, rough running just after startup usually clears up once the parts start warming up. That's the morning sickness. Intermittent loss of power, it's just short jolts, vibrations felt during flight. They don't last long, but it's enough to get your attention. And nose kicks on the helicopters, basically you're losing a little power, so that you're gonna get some nose kicks, and that's the way to know if you're flying a helicopter. Early causes, high silicon. I mean, it's dirt and oil. I don't want to simplify it too much, but basically that's what it comes down to. The higher CHTs, a lot of silicon in your oil. These are types of things that you want to keep an eye out on if you seem to struggle with valve guides. Of course, always feel free to talk to our product support team. Their presentation doesn't have each and everything in there, but those typically is what causes a valve stick is dirt and oil, dirt and high temperatures. So here's some things that could happen. You can get damage to the push rods, and then you get some case damage in that area. That's listed. I've seen this a few times. That's where we got the picture from. The pinched push rods can chip pieces off the edge. If you look at that TAPPET body, it's basically almost the same diameter and profile of a push rod. So these are typically tear down fixes. The rocker tip could break. You can see some excessive force on the rocker arm where it's leaving some indentations in the rocker arm, which will need to be replaced. Push rod damage. Of all of it, that's probably one of the better case scenarios because it doesn't require full engine teardown because you don't have to replace the TAPPET body. If that ever does happen to you, we have a service instruction for a valve failure, and that's a service instruction 1193 alpha. Compression checks, we recommend every 100 hours, or if you're having any issues with the engine itself, power loss, hard starting, high oil consumption, we recommend doing a compression check. Our service publication on that is service instruction 1191. 1191 has a specific orifice size and inlet air pressure. So we don't have a couple different for different cubic inches of engines, cylinder size. We recommend one sort of tool with a specific orifice size, and that service instruction 1191 lists all of that. So you want to be 60 psi or higher. The differences between the cylinders should be no greater than 15. And if it is, we want you to check again in 10 hours. So when conducting one of the tests, let's listen to see where it's coming from. This might help us in the future troubleshoot it down. So it's coming out of the exhaust and induction or oil level, and that kind of tells you where it's leaking past. And of course, always be careful. You don't want to have a near miss and get hurt. So watch out for the propeller blades. Cylinder changes. So if you get to the point where you change a cylinder, we always recommend making sure you put torque back on the through studs. And we have a tool for that, ST222, but you can make some locally. But basically what we want to do is when you move a cylinder, we want the torque to go back onto the through studs. So refer to our overhaul manual or our service instruction 1029 on the torques of how we would like it to do while you're waiting on a cylinder or whatever you're doing. You're gonna let it sit for a while. When changing a cylinder, we want new piston rings. When the cylinder is removed, we want the barrel to be honed. Always clean the hydraulic plunger assemblies and check dry tappet clearance upon reinstallation. Do not use any magnets when removing the hydraulic plungers. And hydraulic plungers are matched and they're not interchangeable. So have a way to keep them in this appropriate location. One exhaust, one intake, keep them all separated. So when going back together, we want a little bit of oil on the studs for torquing. And then once you have them installed, follow service instruction 1427 to break in the new cylinder. So let's get into engine preservation. We have a pub on that as well. Service letter 180. Basically high level on that service pub is we recommend anything that sits for more than 30 days to have some sort of preservation. For high corrosion environments, along the coasts, around moisture, you might want to change that 30 days into something a little more practical, a little better for your environment. The preservation process requires removal of the engine oil and replacing it with a preservative oil. Service letter goes through that and it lists a recommendation as far as the preservative oil mixture. Dehydrator plugs in all the cylinders are recommended, and desiccant bags can be installed in the induction and exhaust for extra protection. Any way to block off air is going to be the best way to keep corrosion out of your engine. So I would recommend doing that. And if you do all that, really mark it correctly with some red streamers to know that something's there and not to start the engine. I can tell you some stories about that as well. We can meet up some other time and talk about that. And once you have everything set, don't turn the prop. Just let it sit, walk away from it. Don't turn it, because once you do that, you're going to start wiping off the precious oil that we want to keep it from corroding. And this is our best recommendations to keep corrosion out of the engine, but prevention is not foolproof. So the best prevention is just flying it. That's not always practical, but that is the foolproof way of keeping out corrosion. So let's go about the resources, some available documents and things for the mechanic who's maintaining our engines. One thing that I find is pretty nice, we have a tool rental program, service letter 234. We offer a program for specialty tools, something that you're not going to want to buy, sledging tools, wobble check tools, clean up seats, oil pressure, those types of things. You can rent those. You got to rent it through a distributor. It's a first come, first serve. Some tools we have quite a few of, some we don't. So if it's a tool you need, I'd recommend checking with and getting an order in soon. There's a nominal fee. Every distributor is a little different. So I don't want to put a number on it, but it's less than 100 for 30 days. We must, 30 days return. So it's a good, nice program to have. So you don't want to invest in a big amount of tools that you're going to use a few times. So I recommend checking that out. And if you have any questions, obviously call me or call our product support team. We have a lot of technical publications online now. So if you don't know, check it out. It's pretty good. If you go to our website, these are all the items that we have on our pub: service bulletins, instruction letters, manuals, parts catalogs, and SSPs. We They're all available, and if you don't find what you need, we can get it to you as long as it's still an active one. Like you're working on a Geo 480, you might not find those. Not that they don't apply anymore, it's just we put the most used and the recent ones online. Something I recommend is registering your email on our website. I've also done this just to kind of keep up to date with things since I'm not in the product support department as much as I was. Put your email in there so when any new publication comes out, it notifies you. And the worst case scenario, if it doesn't apply to anything you're maintaining, you can delete it and move on. So here's our technical support contact information. I won't read out those phone numbers there. You guys can kind of take a screenshot of that. But yeah, those guys are available 8 to 6. And if you're just busy and you want to email them, technical support at lycoming.com, I recommend that. They all have access to that and they all check it regularly. We also can do it online. Do you want to submit something online? So go to Lycoming, go to contact and support, scroll down and fill out your information, hit the submit button, and an email will be sent to our technical pubs team and our technical product support team, and they will get back with you with whatever you're requesting. So one thing I like to do, recommend you do is if you're really getting into some troubleshooting, always is a strong word, but boy, it makes it a lot easier. We can get it done quicker if you include some of these things. Let's get the engine model, serial number, time and service, a detailed and objective description of the observed condition. You know, if you're having an issue and it only happens above 5,000 feet or only happens at idle or happens at power settings, mid-power, that'll help start wheels turning and figure out what's going on a little quicker. So let us know what you've done so far. We may ask you to do it again, or maybe we have a different way to do it that may get it done quicker. And I mean, we're 2022, so I've done videos. We've FaceTimed some people before when they're showing what happens when you advance the throttle. And all that stuff can be shared with our product support team, and we can get you where you need to go quicker. So that's all I have. I appreciate everyone tuning in to this IA presentation. I want to thank Chris for putting this on. And if you have any questions, feel free to contact us. Thank you. Bye.